Okay, let me confirm if it's working. Okay, perfect. So hello everyone, my name is Favour. Let me confirm if it's working. And okay, let me move that. In this course, I'm going to be showing you how to build a linear regression model using Pandas, Matplotlib and Scikit-learn. Okay, so now we are going to be using the data from Kaggle. Okay, so this is the data that we are going to be using to build a linear regression model. This data contains over 100 years of trading of Coca-Cola stock price. And the tool that we're going to be using, okay, our ID is going to be Coca-Cola. So let's open Coca-Cola. Okay. And I'm going to create a new notebook. And one importance about Coca-Cola is that you don't need setup in Coca-Cola. Okay, you can use it on the go, right? You don't need to install Scikit-learn or any library. Okay, so first of all, let's rename our project. I will name it Coca-Cola stock prediction. Okay, yeah, and okay, it's connecting. Yeah, perfect. So first thing we need to do is we need to get the data and we need to clean the data. Okay, so when building the model, when building a linear regression model, okay, you have to make sure that the data is like cleaned. When I mean cleaned, I mean that you have to remove null value from the data and like clean it for the model to use. And we are going to be loading the data directly from Kaggle. Okay, that is a very like an easy way to do that. Okay, so let's import pandas. Import pandas as pd. So pandas is a library. Pandas is a Python library used for cleaning data. Okay, like manipulating your data. So let's say you have a large CSV file. You can perform different operations using Canva, and that's what we're going to do now. So first of all, let's get the data from Kaggle. And for you to use Kaggle, you have to like authorize, like you have to give authorization. Okay, you have to provide a JSON file, which I'm going to get from Kaggle for you to like access it through Coca-Cola. Okay, so first of all, I will need my API key for me to access the data directly from Kaggle. So when you go to your setting and okay, and you click on API key, if you can see this, let me zoom in, this create token, you click on it and you click on continue. It's going to download a JSON file, and it's what we are going to use this JSON file to access and to have access to the Kaggle dataset that we are going to be using for this project. So now we'll go to Google Colab, and first of all, let's import OS because we're going to be using that too. So import OS, and yeah, and let's go back to our data set. Now to use this data set, we need to download it, but we are going to download this directly to Google Colab. So click on download, then this file part, all you have to do is to copy this file parts and I'll paste it here. Okay, but we need Kaggle up too, so let me import Kaggle up, and here we go. Okay, perfect. Okay, nice. So now we've given the path. Now we know the path to the data set, but we can't read it directly. Let's try it. If I say let me say data frame equals to pd dot read csv, read and I pass in the path, it's not going to work, right? It's going to give you an error. Okay, so first of all, we have to load the data sets. Okay, this is just the path to the data set, but we have to like extract features, like extract the main file path from this. So first of all, for us to reach the data set, like I said earlier, we have to provide the API key for us to like get access to the data. So first of all, let's create a directory. Okay, and we are going to specify the path to the directory. So to the directory, I'll name it cargo. I'll name the file path cargo, and okay. Now, yeah, I'll specify the path, like the file path, make directly the path where I want to store my JSON file, right? So now I have the path. But first of all, okay, so can you see this? Yeah. If if you look closely, you see that we've created our path. Okay. So next thing, we downloaded a JSON file. Okay, we downloaded a JSON file. So next thing that we're going to do is we are going to upload the file to our Google Colab so we can read it directly. So I'll click on this upload button and find the file. Okay, should be in my downloads. I have it somewhere. Okay, yeah. So this is the JSON file that I downloaded from Cargo. So I'm going to click on it and click on open. Okay, and as you can see here, we have our file. So I'm going to go out from this. Our next thing is we are going to copy our JSON file into this directory. Okay, so you have to use an exclamation mark since you are on Google Colab. Okay, we are going to copy the file. Then specify. Okay, yeah, the autocorrector is already giving us the file, and specify the path cargo. Yeah. So basically, what is happening here is we've created a directory, right? Like a folder, and we named the folder cargo, right? And now we need to provide the file, like we need to provide the JSON file. Okay, so to give us authorization into the dataset. Now we've copied the JSON file. Okay, this CP means copy. So we've copied the JSON file into this directory, into the cargo directory. And now let's see what happens. Okay, perfect. Okay, yeah. So next thing we need to do is to like guess the name of the file path, because this file path provides a list of where we can have access to the data set. Okay, so let's say a list. So let's find out where the data set is. So if you look closely, you will see the parts of our data set. Okay, so this will give us list of part of our data set. Okay, and we are going to use one of them. So next thing is to load the CSV dataset. So I'll do CSV parts. Where's dot join dot parts. Okay, and we'll provide the parts and this one of them. Okay. Okay, I think there's an error. So let's try fixing that. It's not os.join.path, it's os.path.join. Okay, os.path. Okay, perfect. Dot join. Okay, perfect. Now if we load the CSV path, we are going to get this. Okay, we are going to get this. So now we don't have like the path to our CSV. Now we can now start building. Okay, so this is time we start building and using Pandas to manipulate our data sets. Okay, so I'm going to create a data frame. Say df equals to pd.read CSV and pd.read CSV, and we pass in our file paths. Perfect. So if I pass in df, yeah, perfect. So now we've loaded our data sets. So this is the CSV, this is the data set that we have. Okay, this data set contains, okay, so this data set contains Coca-Cola stock price over 100 years. Okay, and if we scroll up, we are going to see detail about this data set. Okay, this data set contains the dates, opening price of the day, highest price of the day, lowest price of the day, and all the informations. Okay, now we are going to be building a linear regression model to predict the closing price of the day for the nearest future. You get right? But first of all, like I said earlier, the first step we're going to do is to clean the data set. So let's quickly do that. Now we have this data set, and this data set has 7 columns and 15,922 rows. Okay, first of all, we have to check for how many rows are empty. Okay, so we're going to do pd df.is.sum, like we have to. Okay, so as you can see, there's no value in dates, and there's no value in open, high, close, adjusted, close, and volume. Okay, so with this information now, we know that our data set is clean. Okay, there's no value. Okay, so next step is to get a full information about our data sets. Okay, like an overview. So we are going to do pd.describe and pd.describe, and this will give us like an overview of our data sets. Okay, like the main, the mask, and the max, and all the information we have about like different columns. Okay, and we can also use df.info to have more ideas about our data sets. Okay, so this is an easy way to like have a general view of your data set. Okay, when you're analyzing, and when we build our linear regression model, we are going to be using standard scaler to like scale the numbers so they'll be in the same range. So next up we know now that our data set is clean. Okay, there's no value. Okay, and now we've gotten a full idea of this. Next thing we're going to do is to create new features. Okay, so right now we have the date, and we have other information here, but this date is not really structured. Okay, so next thing we're going to do is we're going to be creating new features from this date. We're going to be extracting the year from the date, and we're going to be extracting the month and the day so the model can like give more accurate prediction. So to create new features, let's do this df.year. So now we are creating new feature. We are extracting the year from the dates, and we'll do pd dot do date time and the data set. Okay, passing the dates. Okay, passing the date. Okay, dt.ca. We are only interested in the year and like, okay, key error data. Okay, what's the error? Let's see. Oh, spelling error. This there. Okay. Okay. And we have to see past this. UTC equals to true. And yeah, it worked. So if you load our data frame, we are going to see that it has 8 columns now. Because before it had 7 columns, but now we created new future, right? We extracted the year from this date, and now we have 8 columns. And if you look at this, you can see the year, and it has the year or the year, right? Okay, from 1962 to 2025. That's the current state. So now we've extracted the year. So next up, we are going to extract both the months and the day. So I'm going to do that quickly. Df dot, okay. So next we are extracting the month. pd dot to this time, and df, we are going to pass in this, sorry, dates, UTC equals to true. Okay, then we have to specify what we want. We are extracting the month, so I'm going to pass in the month. Okay, dt dot UTC. Okay, oh, error. Okay, perfect. dt dot month should work. Closing bracket does not match. Let's see what's the error. Oh, okay, yeah, that's it. Yeah, perfect, it works. Okay, now let's do same thing for D. D and pd dot to date time df. Okay, we are extracting the future from the dates, okay, and passing UTC equals to true, and okay, yeah, okay. And when we run our code, it works. And when we run this, excellent. So now we have 10 columns. Okay, we've extracted the year, the month, and the day from this data set. So now that we have what we want, we are going to drop this. We are going to drop this particular column, this column, because it's no longer important. We have this already. Okay, so an easy way to do it is with, of course, Pandas. So I'll do df, okay, equals to df dot drop, okay, dot drop, df dot drop, okay. Then I pass in what I want to drop. I am dropping, let's see, okay, I'm dropping dates, let's see, and axis. From axis is the column, that's one. Yeah, let's see. Okay, it's worked. So if you go to df again, you'll see that we have only 9 columns. And we have dropped the date, because the date is no longer important, right? We have our year, we have our month, we have our day. Now we've extracted the futures from this date, and like we have this. So now we can work with this. Perfect. So next thing we are going to do is we are going to visualize our data. So now we have our data sets. Okay, we've checked our data sets, and we've seen that there's no value here. Okay, it's already cleaned for us, right? And we have an overview of our data sets here, and like also the information, right? Yeah. And also this is also showing us the data type. Okay, open, high, low, and close has in float 64 data type, and the volume has like in 64 data type. So next thing we're going to do is to visualize our data. But first thing first, let's drop no value. Okay, there's no value, okay, but let's assume that our data is going to increase in the future. Okay, so I want to build this model, or let's build the model in a way that whenever it sees in a no value or any duplicate value, it drops it. Okay, so we are going to do df dot, because df dot drop now, to drop a value, and run the code, and we do df dot drop duplicate. So whenever it sees a duplicate value, it drops it, like it removes it from the data set. Okay, so next up, we've dropped every non value, right? And we've dropped like duplicate values in our data set. So, okay, this will enable the model like make accurate prediction. Okay, so next up, we are going to visualize our model. So I'll write it there. Okay, so I'll put next step. So all right, visualize data. Okay, visualize. Okay, so next step is to visualize the data sets. Next step, visualize the data set, and the tool that we are going to be using for visualizing the data set is Matplotlib. Okay, so you can visualize your data set with Matplotlib and Seaborn. Okay, so we are going to be using that to visualize our data sets, because from this data set is Coca-Cola stock price over 100 days of trading. Okay, so from 1990 to 2025. Okay, so let's quickly do that. Okay, and first of all, we have to import the library. So import Matplotlib. Okay, yeah, that's here. So that is one importance of using Coca-Cola, because Coca-Cola, you don't have to like set up your environment before you can start coding, right? Like you just have to go to Coca-Cola and like start coding on the go. So that's one of the major importance of Coca-Cola. Okay, so now we've imported Matplotlib. So next up is to plot our graphs. Okay, but don't forget, this is the information that we have. We have our open, we have our high, we have our low, close, adjusted close, volume, and all this information, right? So let's try visualizing. Okay, so let's try visualizing like the close over the past years. Okay, yeah, plt dot plots. Okay, so we are plotting our x is our close, then we pass in our year. Okay, passing the x label. For the x label, we have close price plt dot y label. Okay, and the y label. Okay, for the y, we have close price, and let's pass in this. Let's see. And where's this dollar sign? Okay, yeah, close price. Yeah, okay, let's pass in the years. And let's try running our code and see what happens. Okay, this is not. Okay. Okay. I think I have to switch this. This is not what I expected. Okay, let's try this instead. Okay. Okay. Yeah, perfect. Okay, and yes. Okay. So as you can see, from this our plots, right now we've plotted a graph with Matplotlib. Okay, and this is showing us the information of our closing price. Okay, let's call this closing price instead. Closing price. Yeah, here we go. So this is our closing price over the course of the year. So as you can see from the data set that we have, it's showing us that the stock price has increased over time. Okay, the stock price has increased over time. Okay, so you can compare two values, okay, using Matplotlib and creating the plots to get an insight of your data. Okay, so for here we can use high if you are trying to compare the high over the years. And let me say high and high. Okay, or let's try visualizing the opening price. I can also pass in open here and name the label opening price, and yeah. So as you can see, same thing. So both for the opening price and the closing price, there's an upward movement in the chart. So it's showing that from 1960 to 2020 and to 2025, there have been an upward movement of the Coca-Cola stock price. Okay, you can also use volume. Let's try it for the last time. Volume. Okay, yeah, volume. Pass volume. Yeah. So this is a visualization. Okay, but I'm going to stick with close because that's what we are trying to predict. Okay, we are trying to predict the closing price for the coming years. Okay, closing price. Yeah, perfect. Okay, we have to give our charts a title. So I'm going to come in and go plt.title. Give it a title. I'll say I'm closing price over the years. And yeah, so now we have our title here, closing price over the years. Okay, so now let's also visualize our data. Let's try using Seaborn. Now we've used Matplotlib to create this line chart. Okay, and there are several you can create several type of graphs using Matplotlib. Okay, now let's use Seaborn to get more insight on our data. So I'll say Seaborn, possible as SNS. Yeah. Okay. We can do SNS dot k. So this are list of what you can create, list of the kind of chart you can create using Seaborn. So let's create a heat map. Okay, let's create a heat map. But first of all, you have to do this. Okay. Okay, we have to pass in our data. We want the heat map of our high. Okay, high, low. Let's see our data sets. Okay, we have open, high, low, close, volume. Okay, open high. Open, okay, close. We have our volume, and we have our adjusted. It's adjusted close or close. Let's check. Okay. Okay, yeah. This instead. Okay. Okay, key error. Okay, this is a list. So you have to pass in the list. Okay, that's the error. That's it. Okay. So this is the heat map, but it does not look good like this. So let's try making this like look better. Okay. So what we do is we're going to pass in the correlation, because we're trying to check correlation between these data sets. Okay, and we're going to pass in, okay, this dot correlation, and yeah. Okay, let's see. Oh, what's the issue? Okay. If like this. Okay. Let's see. Okay. Let's see. Attributes error data format no fair. Oh, that's the error. I used only I used only one arrow and it gave me the error. Okay, so it's correlation, because we're trying to create a correlation between different data sets. Okay, perfect. Okay, so let's try it. So for the data sets, we're going to pass. Okay, I'm going to use 2R for this. We are going to pass in the correlation. Okay, and let's check. Okay, it expects a data set. Okay, and this. Okay, and we are going to provide anode keywords to true. So it's keywords numbers, right? And the place for style. Let's check. Okay, CMap. Let's use the style. Oh, okay, let's see. Correlation not even. Okay, yeah, let's pass in this. Perfect. So as you can see now, we now have a view of our data. Okay, so this is a heat map. Okay, this is a heat map, and we are trying to like visualize our data. Okay, so from our data we can see that close, open, low, high, like they have the same relationship. Do you get? Okay, so close, open, low, high, they have similar relationship, and like yeah, even adjacent close, they have similar relationship. But when you come to volume is quite far. Okay, like volume is like somewhere here, and these three are like there at the top. Okay, so like this is an easy way to use like Seaborn to visualize your data. So now we've used Seaborn to visualize our data, and we've also used Matplotlib to visualize our data. So from this data set, we know that there's an upward movement of the Coca-Cola stock price, and like from this Seaborn charts, we know that okay, this 4, or let me say, and these 5 elements, okay, they have similar similar features. Okay, and this anodes equals to true, and will help us like see a view. Okay, let me say I remove this. I remove this and click on enter. Yeah, the number is going to disappear. Okay, so okay, that's why we put this anodes equals to true. And when you run your code, it's going to like show you a number on top of like every element or every data set. Okay, perfect. So next thing that we're going to do is we are going to build our model. Okay, and we are going to build our linear regression model. Okay, and we are going to be using the scikit-learn Python library. So we're going to import scikit-learn, and don't forget we are building a linear regression model. Okay, and scikit-learn has a library for linear regression. Okay, so scikit-learn dot linear model scikit-learn dot from scikit-learn to import linear regression. Okay, perfect. Now for us to build our data, for us to build our linear regression model, we have to split our data into training sets and testing sets. Okay, so for us to split our data, we have to import the train test split like function from scikit-learn. So let us import this quickly. Okay, let me see from scikit-learn. Let's say preprocessing import train. Okay, no, okay, sorry. Yeah, from model selection, import train test split. Yeah, perfect. Okay, so the next step that we're going to take is to split our data sets into training and testing. Okay, so the next step we're going to take after, okay, now we've built our model, right? We've cleaned our model with pandas, right? And we've cleaned our model using pandas. So next thing we did was we visualized our model using Matplotlib and using Seaborn. So next step is we are going to start building our model, but before we start building our model, we have to split our data sets into training sets and into testing sets. Okay, and we are going to be using train test splits. Okay, and we've imported it from scikit-learn. So next step is to split our data sets. Okay, so we are going to have a string. I'm going to write that here. Okay, say splits our data sets into training and testing. Okay, perfect. So we're going to split our data sets into training and testing. Okay, so I'm going to write s train, s tests, okay, y tests, y train, percentage train, and passing the train. Okay, so now we have to pass in our data sets. Okay, we have to pass in our data set. But first of all, before we do that, we have to specify our target and our label. Okay, so now we are trying to predict the closing price. Okay, we are trying to predict the closing price over the years. Okay, and we are going to be using these features. Okay, we are going to be predicting the closing price using the open, high, low, adjusted close, volume, and other information, so including the years. Okay, so let's define our x and y. Okay, df.drop. I want to be dropping the closing price and axis equals to 1, and there we go. So what I basically did was that my whole data frame is going to be the label, right, but not including the close. Okay, so if I run my X, yeah, as you can see it has only 8 columns and the close is no longer here, right, because of how I dropped it. Okay, so next off we are going to define our we are going to define our targets, like what we are trying to predict, and we are trying to predict the close, right? So yeah, perfect. Okay, so now that we have our X and Y, we are going to be splitting these data sets into 80% for training and 20% for testing. Okay, so in this train test split, okay, you can also use this docs string. Okay, it for the parameter, it expects an X value and a Y value. Okay, and that is what we've defined here, like our X and Y, right? Like the target variable and the labels or the fusions. Okay, so next thing we are going to pass in our X and Y. Then the test size is going to be 0.2. okay, so this 0.2 simply means that it's going to use 20% of the data for the testing, okay, and 80% is going to be for training the models. Okay, so let's run our code, and perfect, it worked. So when you click on X train, let's try checking the size. Let's see if it's okay. It's not callable. Okay, yeah, let's see. Yeah, or should I say, can we use shape? Let's say. Okay, let's see X text. Okay, yeah, perfect. So as you can see, our data has been splitted. Okay, our data has been splitted. So now that we splitted our data, next thing is to train our model with the testing data. Then after training the model with the testing data, we are going to test this with our test data, right? Yeah. So next up, now that we've splitted our data, we are going to start building our model. Now we are using linear regression model. Okay, I'll put the test here. I then build a regression model with build a linear regression model. Yeah, I'll just leave this to build a linear regression model. Perfect. So next step, we are going to build a linear regression model. So we are going to build our FX machine learning model. Okay, so we have to create an instance of the model, right? So instance of the model, create linear regression and like passing. Okay, now that we've created the linear regression model, we have to train our model with this data set. Okay, so we'll use model dot fit. Okay, so this model dot fit simply means like you are training the model, you are fitting the model, right? And you are going to pass in the S train and the Y train. Okay, found input but with inconstant. Okay, S train and Y train. Okay, where is the error coming from? Let's see. Okay, let's see X train, Y train, X tests. y tests. I think, yeah, I think this. Okay, let's try fixing our error. Where is the error coming from? We have our training data sets, we have our test data sets. Oh, okay, yeah, and that's where the error is coming from. Y train y test, and we run this. Okay, should work. Perfect. So now we've built our linear regression model. Okay, but we have to pass this you have to pass in some parameters. Okay, pass in the random states. Let's see. Let's find it. Let's just leave it for now. Okay, so now we've built our linear regression model. Okay, so this is an easy way. Okay, so we've gotten our model. Let me go through the step from beginning. So first of all, we read our data set from Cargo. Okay, so next thing that we did was we cleaned the data set. Okay, we cleaned the data set using df.drop. Okay, yeah, and next thing we did was that we created a new futures. Okay, we created new futures from the data set. Okay, we created futures like we created year, months, and day, right? And we dropped our data. We dropped the dates after like extracting the futures from the date. So next thing we did was we dropped duplicate values and we dropped like null values. Okay, and next step that we took was we visualized the data using Matplotlib, and after visualizing the data we created a heat map using Seaborn. And for the model building we splitted our data into training and testing. And now we've built our training data set and we've built our model. We've built a simple linear regression model using like Scikit-learn. So next step is to check the performance of our model. Okay, so to easily check the performance of a model, you have to just do model.score and passing your S-test data sets and Y-tests. Let's see. What parameter is score expecting? Okay, yeah. So score is expecting X and Y data sets. So let's see the score of our data set. So if you run it, wow. So we have 0.99999. Wow, accuracy. So basically what this is trying to tell us is that we have 99% accuracy. So 1 is like 100%, like 100% accuracy. So the closer your model, the score of your model is to 1, the better the accuracy. Okay, and our model has 0.99 accuracy, which is like very impressive. So congrats, you've built a linear regression model using Python, okay, using Scikit-learn, Pandas, and Matplotlib. Okay, so a way to make sure that, okay, so now that we've built our model, a way to make sure that our model performs very well is to scale the data. Okay, so you can choose to scale your data sets. Okay, this number you can choose to scale it so they'll make more accurate predictions, right? So to do that, okay, let's quickly do that. So we are going to be scaling our data and we are going to be creating a pipeline to automate the process of building our model. Okay. To copy this, and yeah, copy this, and we have. So now we are going to separate the futures equals to and dates. Yay, months and day. Okay. So now we've separated our future. Okay, I'm going to remove close. So next up is to scale these futures. Okay, we are going to scale the futures, and after scaling the futures, we are going to merge it with our date. Okay, so we are going to scale and merge the date, and we are going to create a pipeline using Scikit-learn. So we need to import it from Scikit-learn. So let's say from sklearn let me see, preprocessing, import standard scalar. Okay, yeah, perfect. Now we've imported standard scalar. Let's also import column. Let's see. So, okay. Let's find it. Where? Okay, let's see. I'm scaling dot processing for standard scalar from scaling dot. Okay, let's check. What's column? Perfect. Okay. So we're going to be using column transformer to scale our data. Then after scaling it, we are going to merge it with our date. Okay, because it's not a good convention to scale both your dates. Okay, so we're going to create, we're going to say pre-processing. Preprocessor goes to column transformer. Okay. Okay, I'm going to pass in. I'm going to add this. Okay, I'm going to explain what is going on in the code. And now what are we transforming, right? On the boot scalar, that should be scalar. Then passing the standard scalar because we're trying to scale our data set. And passing what we are trying to scale. So now we are trying to scale okay, I'm sorry that I had network issue. Okay, so let's continue. So now we've scaled our data, right? So next up, we're going to add our other data sets. Okay, so let's do this quickly and let's add our dates. So now nothing is going to happen to our date, so we're going to use pass through. Okay. So this pass through simply means that it's not going to affect the date. It's going to give it the date as it is, right? No passing the dates. Yeah. dates. Okay, so okay, perfect. So now we've created a transformer. Okay, so now this value is scaled. It has scaled these futures, okay, and it left this date how it is, right? So now we can load the scalar and see what's going on. Scalar is not defined. Okay. Let's see if you load the processor. Transformer is creating a pipeline. It scaled these futures, right? It scaled this high, volume low, and and this adjacent close. Okay, so they'll be in the same range, okay, to avoid bias when the model is making prediction. Okay, so this is is used to avoid bias when building models. And this pass through is the date. Okay, I use this pass through to skip the dates. Okay, so it's not going to apply any transformation to the dates. Okay, let's see this. Yeah, it's not going to apply any transformation to the date. It's going to just skip it and give you how it was without applying any transformation. And this standard scalar is going to scale this, okay, and apply the standard scalar. So next up, now that we've created our column transformer, we are going to create a pipeline. Okay, we are going to create a pipeline to automate the process. So I'm going to pass in pipeline. I'm going to create an instance called pipeline. Okay, but first of all, I think let's install pipeline. So from scikit-learn dot pipeline, import pipeline, and let's go. Okay, so now that we've imported pipeline, let's create a pipeline. Okay, so I'll say so the last step I'm going to do is to create a pipeline. So instead of doing linear regression dot fit, we are going to create a pipeline to go all through those process step by step, right? So we are going to do pipeline and create an instance pipeline equals to pipeline. Okay. And let's do same thing over the steps. Okay. Then we'll pass in the steps here. Okay. Yeah. Perfect. So the first thing we're going to do is to pass in our transformer. So we are going to pass in preprocessor, and pass in the preprocessor. Okay. So let's see. Okay. So the preprocessor is going to scale our data, right, and measure with the date. Then after measuring with the date, it's going to create a pipeline and follow through the process. Then after passing through the preprocessor, okay, let's see, she's given an error. Okay, let's try to see the error. Okay, saying let's see our pipeline. Let's read through the doc string to see the process. Okay. Okay, so we don't need this. Yeah. Let's go over the process again. Okay. So to create a pipeline, let's shake through the doc string and see the process. Okay, you have to create. Okay, perfect. Okay. And we have this. So I have our preprocessor. I'm passing the preprocessor here. Yeah, perfect. So now next thing is to pass in our linear regression modules. Okay. Sorry. Say linear regression. Do I need to call it? Let's see. Okay, yeah, I don't need to call it. Okay, let's see. So let's try creating top is not callable. Let's see. Model. Okay, I see my error. Yeah. And when we run this, top is not callable. Okay, and yeah. So now what we've basically done is we created a pipeline to perform transformation on our column. Then after we created the pipeline, we went here. Okay, I think, do we have to call it? Let's check. Oh, yeah. Let's say the doc string for the step. Okay. Yeah, we need to call it. Okay. Yeah. So now that we've created the pipeline, let's view our pipeline and say view. Okay. So yeah. So basically, what we did was that we created a preprocessor, okay, a column transformer to perform this operation on our column, right? To perform standard scalar on these futures, and when it's done, it's going to merge it with the date. Then after that, I created a pipeline, okay, a pipeline to like go through this process step by step. So from top to bottom. So after applying this transformation through the pipeline, I'm building this model, okay. So we passed in this model, okay. So instead of us to like use this process, okay, like instead of like writing model.fit and model.score, we can just go through the process. So I'm going to delete this to delete this. So we are going to be using our pipeline instead, okay. We are going to be using our pipeline instead. Let me check. Okay, so let's check our score using our pipeline instead. So now that I've created our pipeline.score and passing our string and white string. Yeah, let's see our score. Oh yeah, that's true. Okay, we need to fit our pipeline. So instead of score, I'm going to put in fit. So okay, network issue. So we've created a pipeline. Okay, basically. So we've created a pipeline for this model. Okay, so now that we've passed in our X train and our Y train, what is basically going to happen is that through this pipeline, it's going to scale our data, right? It's going to scale our futures, these futures here. It's going to scale the high, low, open, volume, and close, right? So after scaling it, it's going to merge it with the dates. Okay, so as you can see, they're going through the same like input, right? So it's going to merge the standard scalar, like the scaled value and the dates. Then after merging, it's going to like perform a linear regression. Okay, so you can create a complex pipeline to automate the process of building model, right? So that's it. So we can simply check the score of our model using pipeline.score. So now that we've trained our model using the training set, we're going to test it using the testing data set. We're going to pass in S-test plus Y. So as you can see, instead of using a linear regression to build it, we created a pipeline and passed in the linear regression. And one importance about this pipeline is you can use different kinds of like you can experiment with different kinds of machine learning model. Let's say for example now we want to use logistic regression. We can just pass in we can just import let me say from sklearn linear models, import logistic regression. Okay, let's see. You can pass this logistic regression and let's run our model. Okay. Oh yeah, I've seen my error. Okay, sorry. So now this is a linear model that we're trying to predict. It's not a classifier. We're not trying to classify anything. So it gave us an error. But let's try using another kind of, okay, let's try using random forest regression and regressor. Okay. Okay, so instead of logistic regression, okay, let's use random forest and just try out random, okay, from dot forests and dot mc3 import. Where can we import this? Okay, sorry, from assemble. Okay, yeah, true. Because random forest is an assemble method. Okay, ensemble import random forest. Yeah, random forest regressor, and like if you run this and like pass this to this. So now we are trying to use another machine learning model that is not a linear model, and if you try this and just watch what will happen, right? Okay, it's currently showing our model, but now perfect 0.999 correction. So with this pipeline you can experiment with different machine learning model. Okay, so we used a linear regression model, okay, and it had a high score. So in just few lines of code we are able to change the model into a random forest regressor to test same data set, and it gave us similar score. Okay, so with pipeline you can experiment with different machine learning model to find one that gives the best results. Okay, so you can try this, okay, with different data set, and it's going to give you similar results. That is one importance of this pipeline. So following through same process, it scaled the data and meshed the data with the date, because it's not a good convention to scale the date to. And after scaling it, it used a random forest classifier. Okay, so same thing happened here, right? So it's a very smart way, right? So let's try it for the last time. Let's try using another machine learning model that's not random forest. Okay, let me see, from XGBoost imports XG. Okay, let's try using XGBoost and regressor, and okay, XGB, okay, and let's pass the regression and see how accurate it is, and what parameter is this expecting. Let's see here. Let's see. Okay, let's just see and run everything and see how accurate our prediction will be. I'm using XGBoost because XGBoost is used the most cargo computations. Okay, I hope it works, hopefully. Whoa, it worked. Wow. Whoa, wow. Okay, it's worked. Nice. So as you can see, we train our model with same data sets. We use different kind of machine learning model to train our data set to check for accuracy. Okay, so XGBoost regression got 0.9 accuracy, and most machine learning model, they got same accuracy. So that is an easy way to like build a linear regression model using Python. Okay, Scikit-learn and Pandas and Matplotlib. So in the next course, I'm going to show you how to upload the course. How to deploy the model how to deploy the model for real world use. So stay tuned and see you later. And don't forget to subscribe.